In today's lesson, we will learn how to compare and describe two fractions with the same numerator. Here is the vocabulary for today's lesson. It is important to note that when comparing fractions, the size of the whole must be the same. For example, if your friend offers you and another friend half of a chocolate bar, she then pulls out a regular and a mini-sized candy bar. Will the halves be equivalent? No. The sizes of the original bars were not the same. Therefore, the sizes of the halves will not be the same. Another note is, like when comparing two whole numbers, the fraction on the right of the number line is the greatest when comparing two or more fractions. Let's look at a fraction table and identify all the unit fractions. Remember, a unit fraction has a numerator of 1. There's 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9, 1/10, 1/11, and 1/12. As we move down the table, our unit fractions get smaller in size. Why does this happen? First of all, we realize all the numerators are 1. Second, we recognize the denominators are all different. As the number of the denominator gets bigger, the size of the equal pieces gets smaller. Or in other words, fractions that have a bigger denominator mean the whole must be divided into smaller, more equal-sized pieces. Let's try a word problem using our candy bars. Johnny ate 2/3 of his candy bar. Bobby ate 2/6 of his candy bar. Who ate the most of their candy bar? To solve this problem, let's create two number lines, one to represent Johnny and the other to represent Bobby. It is important that the size of our whole or our number line be the same size. To solve the problem, divide Johnny's number line into 3 equal pieces. Divide Bobby's number line into 6 equal pieces. Each denominator is different, but the numerators are the same. We should realize that 2/6 will be smaller or less than 2/3 because the 6th denominator requires the whole to be divided into more, smaller, equal-sized pieces. Let's shade in 2/6 and 2/3 on our number line and compare and see if we are correct. We can see that 2/3 is more than 2/6. Therefore, Johnny ate most of his candy bar. Now let's look at some other examples. Let's compare 3/8 and 3/4. Here is one whole. First we have the fraction 3/8. The denominator of 8 tells us that the whole has been divided into 8 equal pieces. The numerator of 3 tells me we have 3 pieces. Now let's look at 3/4. The denominator is 4, which means our whole has been divided into 4 equal pieces. The numerator is 3, which means we have 3 pieces. What do we notice? 3/4 is greater or larger than 3/8. Why? Let's look back at our unit fraction list to see if we can make any connections. The numerators are 1. Well, the numerators are not 1, but they are the same. The denominators are different. As the number of the denominator gets bigger, the size of the equal pieces gets smaller. Or in other words, having a bigger denominator means the whole must be divided into more smaller, equal-sized pieces. In today's lesson, we learned how to compare and describe fractions with the same numerators. We reviewed that when comparing fractions, each whole being considered must be the same size and shape. When comparing fractions with the same numerator, we need to look at the denominator. We learned that the bigger the denominator would have smaller pieces because the whole needed to be divided into smaller, equal-sized pieces. As a result, the fractions with the larger denominator will be less than or smaller than the fraction with the smaller denominator.